Assalamualaikum and hi. So we are from group VLAN 2. We will present about network management and on how workflow, security, architecture and step-by-step of the program. So please stay focused throughout the presentation and good luck. So I will pass this presentation to Shakila to present about the network management introductions.
We will discuss about the critical realm of network management and explore its multifaceted role in helping organizations achieve their availability, performance, and security goals. Network management plays a pivotal role in ensuring that an organization's network functions optimally. Its primary objectives are to achieve availability, performance, and security goals. This involves not only monitoring but also adjusting network parameters to meet design goals effectively. Designing a network management system is a critical step in ensuring the long-term success and efficiency of an organization's network. It involves careful consideration of various factors that contribute to scalability, traffic patterns, data formats, and cost or benefits trade-off. In crafting our network management strategy, we must identify and prioritize the resources that are most critical to our operations. Simultaneously, we need to establish clear metrics for measuring performance. This involves defining what success looks like for our network and establishing benchmarks that are allow us to track and assess our performance. Data is the lifeblood of network management, but collecting too much or too little can be equally detrimental. We need to define what data is essential for our purposes, balancing the need for comprehensive insights with the importance of respecting privacy and minimizing unnecessary data. Proactive management involves more than just addressing issues as they arise. It is about forcing challenges and strategically optimizing network performance. First, plan to check the health of the network during normal operation. This ensures that we can identify and address potential concerns before they escalate into critical problems, maintaining the seamless operation of our network. Being proactive requires a keen eye for potential issues. By implementing monitoring systems that analyze network behavior in real time, we can recognize anomalies and deviations from the norm. This enables us to address a potential problem in their early stage, preventing them from evolving into major disruption that could impact our organization's productivity and efficiency. For optimized performance, this involves continually fine-tuning configurations, adjusting resources allocations, and implementing best practices to enhance overall efficiency. Proactive performance optimization is an ongoing commitment to excellence. Plan upgrade appropriately, like anticipating feature needs, analyzing current network behavior, and applying upgrades strategically. This ensures that our network remains not just current but also prepared for future challenges. Next, we explore the structured framework that ISO standards provide for effective network management. ISO delineates key processes that, when implemented, contribute significantly to the reliability, security, and efficiency of network operations. In the realm of network management, faults can disrupt operations and hinder productivity. ISO emphasizes the significance of fault management, a process dedicated to identifying, isolating, and rectifying network faults promptly. By doing so, we minimize downtime and ensure the continuous and smooth operation of our network infrastructure. Configuration management is a process that involves controlling and managing changes to network configurations. By maintaining a clear record of configurations, we enhance our ability to troubleshoot, ensure consistency, and most importantly, safeguard against unauthorized alterations that may compromise our network's integrity. Accounting management is, as per ISO standards, is the process of keeping track of network resource usage. This includes monitoring bandwidth, utilizations, data storage, and other critical resources. While performance management as a dedicated process for monitoring and optimizing network performance, this involves establishing metrics, setting performance goals, and continuously assessing and improving the efficiency of our network. Lastly, for security management, ISO emphasizes this process to ensure the implementation of robust security measures, protecting our network against unauthorized access, data breaches, and other security risks. By following ISO standards in security management, we fortify our network defenses and safeguard sensitive information.
Hi, I'm Arnie Azira. I will be talking about fault management. Fault management is one component of FCAPS, fault management, configuration, accounting, performance, and security, which is a network management framework established by the International Organization for Standardization (ISO). For fault management, workflow is the component of network management that detects, isolates, and fixes problems. When properly implemented, network fault management can keep connectivity, applications, and services running at an optimal level, provide fault tolerance, and minimize downtime. Fault management systems are platforms or tools designed specifically for this purpose. An network administrator can also configure fault management system to automatically fix or prevent certain events using programs and scripts. For configuration management, devices whether on or off a network can often be installed in several different ways, and they can be configured differently by each person who installs them. A configuration management system can help us provide a standard configuration for various devices and manage allowed customization. This kind of system can also be used to build and maintain an inventory of network attached devices. Such tracking protocol (VTP) is useful for updating switches with information about VLANs. Networking configuration management is a process that every device on a network is subjected throughout its life cycle. And if your network environment is handled manually, network configuration management becomes a tedious task for admins. And infrastructure manifold and also reduces management overhead of admins. For accounting management, the text explains that the purpose of accounting management software is to measure use of a network, typically for billing for actual usage. There is also a value to such a system as a problem detection tool, because it will detect large-scale usage of network resources which can be examined for abuse or actual business need. Accounting management is primarily concerned with determining the utilization of network services by individuals or groups of users and regulating such usage according to policy and or also actual business need.
Assalamu alaikum. Now we move on to performance management. As it's explained in this chapter, it's split into 6 things. The first one is monitor end-to-end performance. It's to keep track of overall performance of the entire network infrastructure. The second one is also monitor the component performance, individual links and devices. It's to analyze the performance of a specific network components such as router, switch, and individual links. The third one is test reachability to ensure the ability to communicate with different network nodes. The fourth one is measure response time. It's to evaluate the time it takes for a system to respond to the requests. Fifth one is measure traffic flow and volume. It's to monitor the amount of patterns of data moving through the network. Lastly, record route change. Document any alteration to the pathways that data takes through the. Okay, second, we move on to security management. As it's explained in this chapter for four things. The first one is maintain and distribute username and password. That means manage user credential and ensure secure distribution. The second one is generate distributed and store encryption keys. That means is to create and share and securely store keys for encrypting and decrypting sensitive information. The third one is to analyze router and switch and server configuration for compliance with security policies and procedures. That means to check network device and server settings to ensure they adhere to established security guidelines. Lastly, collect and store and examine security audit logs. That means to gather and retain and review logs that track security-related events for potential issues or breach. Okay, we move on to the third part. As explained in this chapter, it's split into three things. The first one is a managed device is a network node that collects and store management information. That means devices within the network infrastructure that gather and store data for management purposes. The second one is an agent is a network management software that resides in a managed device. That means software embedded in a managed device to facilitate communication between the device and the network management system. The third one is a network management system, that means NMS, runs an application to display management data, monitor and control managed device, and communicate with agents. That means is software that operates application for visualizing data and managing devices and interacting with agents to ensure efficient network management.
My name is Nur Safa Karinisa and I will be presenting about the network management architecture. For the network management architecture, it can be divided into a three layer. First layer is a network layer, second layer is the data layer, and third layer is a visualization layer. And for the first layer, which is a network, it will interact directly with the network. And this layer contains network discovery and pooling functionality. And network discovery retrieve a topology data and network pooling retrieve event data. And for the second layer is the data layer stores the topology data retrieved by a network discovery and the event data retrieved by a network pooling. And the network pooling also includes storage of pooled SNMP and ICMP data for reporting and analysis. And this layer also provide root cause analysis functionality that correlates topology and events to determine the source of the network faults, and even enrichment functionality that adds topology data to the event. And the third layer is visualizations. It will provide the tool that operator and administrator needs to view topology and view events and run network troubleshooting tools. So there is two types of the network management architecture, which is in-band and centralized. In in-band, it's more easier to develop, but in management data being state tested by network problem. And for the centralized, it's simpler to develop and maintain, but require a huge amount of information to travel back to a centralized network operation center, which is NOC. So there is two types of the network management architecture, which is in. For the simple network management protocols, it's for collecting and organizing information about a managed devices on IP network, and for modifying the information to change device behavior, and device that typically support SNMP include the cable modems, routers, switches, server, workstation, printers, and more. And this SNMP widely used in the network management for network monitoring. SNMP exposes management data in the form of variable on the managed system organized in a management information base, which is MIB, and which describes that the system status and configuration. This variable can then be remotely required and in some circumstance manipulated by managing applications. And there's a three significant version of SNMP that have been developed and deployed. SNMP version 1 is the original version of the protocol, and more recent version like SNMP version 2 and version 3. The features improvement in the performance of the flexibility and security. For the remote monitoring, which is RMON, is to provide a standard information that a network administrator can use to monitor and analyze and troubleshoot a group of distributed local area network, which is LANs, and interconnecting T1 or E1 and T2 or E3 lines from a central site. For the remote monitoring, which is RMON, is to provide a standard information that for the Cisco tools is we have two, which is Cisco Discovery Protocol or the NetFlow accounting, which is an applications. And for the Cisco Discovery Protocol, we usually use a CDP, Cisco Discovery Protocol, that we have learned in computer network before, and it is used to share information about other directly connected Cisco equipment, such as the operating system version and IP address. And for the NetFlow accounting, it's like a apps more kind of same with a Wireshark that can view a network performance. And I think that's all from me. So I will pass the presentation to the next presenter.
In the network security design, there is a program called the 12-step program. So the first step will be identify network assets, analyze security risk, analyze security requirements and trade-offs, develop a security plan, define a security policy, and the sixth step will be develop procedures for applying security policies. Next will be develop a technical implementation strategy, achieve buy-in from users, managers, and technical staff, train users, managers, and technical staff. The 10th step will be implement the technical strategy and security procedures, test the security, and update it if any problems are found. And lastly, the 12th step will be maintain security. The first step will be network assets. So network's asset essentially means cataloging and understanding the elements within a network that require protection. Network assets encompass a wide range, so enabling a comprehensive and tailored approach to safeguarding the critical components of a network from potential risks and threats. So network assets will include intangible assets and also physical assets. Intangible assets would be network hosts, inter-networking devices, network data that traverse the network, and others. So for the physical would be intellectual property, trade secrets, and company reputations. The second step would be analyze security risks, such as hostile intruders that poses a triple threat to the network security, data theft, aiming for personal and financial information, data modification, compromising integrity and reliability, and service denial, causing disruptions through attacks like denial of service, DOS. Consequences range from financial losses and reputational damage to significant downtime, impacting business operation and customer experience. Implementing robust security measures is crucial to thwart this risk and safeguard network assets. Next will be untrained users. Lacking awareness can unintentionally jeopardize the network security by clicking on malicious links, falling for phishing scams, or even downloading infected attachments. Moreover, downloading applications from untrusted sources introduces malware, risking data breaches, system instability, and unauthorized access. So vigilance and user education are crucial for mitigating this risk. Next, we will have DOS attacks that are increasing using techniques like network flooding and exploiting vulnerabilities. Their goal is to disrupt access to websites and applications. Implementing robust protection measures, including traffic filtering and redundancy, is crucial to maintaining service availability. And lastly, risk analysis involves identifying and prioritizing network vulnerabilities, assessing software weakness, misconfigurations, and potential entry points for attackers. Prioritization is based on impact and likelihood, guiding effective resource allocation, implementing security controls such as firewalls and encryption, coupled with ongoing monitoring, ensures adaptability to evolving threats. Step 3. Analyze security requirements and trade-offs. When designing a secure network, crucial trade-offs must be considered for a balanced and effective system. First of all, affordability. Security comes at a cost. Striking a balance between robust measures and budget constraints is key, ensuring security aligns with financial resources. Usability. Finding harmony between stringent security and user-friendly interfaces is about safeguarding without hindering the productivity or even the user experience. Performance. Optimizing security to avoid impacting the network speed and responsiveness. Efficiency is maintained without compromising on safety. Last but not least, availability. Balancing security with the Step 3. Analyze security requirements and trade-offs. When designing a secure network, crucial trade-offs must be considered for a balanced and effective system. First of all, affordability. Security comes at a cost. Striking a balance between robust measures and budget constraints is key, ensuring security aligns with financial resources. Next will be usability. Finding harmony between stringent security and user-friendly interfaces is about safeguarding without hindering productivity and or user experience. Next will be performance. Optimizing security to avoid impacting network speed or responsiveness. Efficiency is maintained without compromising on the safety. Availability. Balancing security with the need for uninterrupted access is about operational continuity and preventing disruptions to essential services. Lastly, manageability, streamlining security measures for efficient administration. Balancing robust security with practical management ensures effective monitoring and updates. Navigating these trade-offs require a thorough risk assessment. Prioritize security measures based on specific needs and characteristics. A well-informed approach creates a network that's both secure and practical for its intended purposes.
Hi, I'm Sharha N, and first of all, I'll be explaining about step 4, which is develop a security plan. As for the purpose, a security plan aims to meet security requirements effectively, and it also outlines the steps to establish and implement robust security measures. It also specifies, as for the resource specification, it also specifies allocation of time, personnel, and resources, and it identifies what is required to build and develop a security policy. And a security plan enables adjustment to the plan over time as needed. Next is step 5, which is a security policy. A security policy is defined as the formal statement of the rules by which people who are given access to an organization's technology and information assets must abide. For the regulatory compliance, a security policy must align with relevant laws and industry standards. It also has to include periodic audits to verify compliance. The purpose of security policy is that it should address access, accountability, authentication, privacy, and computer technology purchasing guidelines. Next is step 6, procedures for applying security policies. The first procedure is that create clear policies, which means write down straightforward security rules that is understandable by everyone. The second one is share policies. Make sure that the employees and the stakeholders knows and understand the rules. The third one is that check for risk. Conduct regular risk assessments to identify potential security threats and vulnerabilities. The fourth procedure is that access control implementation, which means enforce access controls by configuring user permissions and roles according to the policy. The fifth procedure is that documentation, and record keeping. Always maintain detailed records of policy implementation, incidents, and changes for reference and future improvements. The sixth procedure is that encrypt sensitive data. Protect important data of the organization using encryption methods. The seventh procedure is that employee training and awareness. Conduct regular training sessions to educate employees on security policies, procedures, and best practices. The last procedure is that incident response planning. Create plans for what to do if there's a security incident in the future. Moving on to the next part, which is security mechanisms. So here are a few security mechanisms. So first of all, physical security, authentication, authorization, accounting or auditing, data encryption, and packet filters, which means to control and filters network traffic, firewalls, which acts as a barrier between internal and external networks, IDS, which is detection systems that monitors and alerts on potential security threats. And finally, IPS, which is intrusion prevention system that actively responds to and prevents security threats. The next part is modularizing security design. Security design can be modularized by a security defense in depth, which emphasizes using multiple layers of security measures and aims to create a robust and comprehensive defense against potential threats. It also involves combining various techniques to protect the network at different levels. The next one is belt and suspenders approach, which advocates redundancy and over-preparation to avoid unexpected vulnerabilities. It is a metaphorical reminder not to be caught off guard and to have a backup security measures in place. Other than that, secure all components of a modular design. The components are internet connections, public servers and e-commerce servers, remote access networks and VPNs, network services and network management, server farms, user services, and wireless networks. The next part is securing internet connections. So, firstly, the physical security. It safeguards the physical infrastructure of internet connections, such as servers and other networking equipments. The next one is firewalls and packet filters, which acts as a protective shield against unauthorized access and potential threats. The next one is routing protocol supporting authentication, which utilizes routing protocols that include authentication features. Moreover, audit logs authentication and authorization, which implements authentication to verify user identities and authorization to control access. And the last one is well-defined exit and entry points. This enhances control over the flow of information and reduces potential points of vulnerability.
Assalamualaikum and hi. My name is Muhammad Alif bin Ahmad Zainuddin. So here I will discuss about the next step in the 12-step program for network security design, which is develop a technical implementation. So let's discuss the first point here, which is security architecture. Here we are talking about designing a comprehensive plan that aligns with our network assets and security policies. This means we want to build a structured framework that incorporates elements like firewalls, intrusion detection systems, encryption methods, and access controls. Moving on to the second point, security technologies. This involves selecting and implementing technologies based on our specified security risks and requirements. We'll be looking at tools such as antivirus software, intrusion prevention systems, and secure communication tools to fortify our defense mechanisms against potential threats. Moving on to the fifth point, data encryption. Data encryption is crucial for protecting information both in transit and at rest. We'll discuss implementing encryption protocols like SSL, TLS for communication and encrypting stored data, ensuring that even if unauthorized access occurs, the data remains secure and unreadable. The next step is achieve buy-in from users, managers, and technical staff. In this slide, it said that engaging stakeholders across the organization is a critical step to foster a collective commitment to security initiatives. This means when we talk about achieving buy-in, we are aiming for more than just compliance. We want everyone on board actively supporting our security measures. Like the title said that from users, managers, and technical staff. For the users, we know that users is the front line of our digital landscape. We need to communicate with them in a way that resonates. This involves ongoing user awareness training, which we discussed in a previous slide. It's not just about telling them what not to do, it's about helping them understand why these security measures matter. When users understand the why, they become active participants in our security efforts. Let's move on to the next step, which is train users, managers, and technical staff. So the purpose for this step is to provide a comprehensive training programs to ensure everyone understands and follows security protocols. So the focus areas for the training first is recognizing phishing attempts. Second one is implementing security best practice. This is not just about theoretical knowledge, it's about instilling good habits. Users will learn how to create and manage strong passwords, practice secure browsing, and secure their devices. Managers and technical staff will receive advanced training tailored to their roles, ensuring that security isn't just a checkbox but an integral part of their daily routines. Last but not least is reporting security incidents promptly. Next, we will discuss about securing server farms. It's about ensure robust protection for server environments through targeted measures. First, we will talk about deploy IDS, which is stand for intrusion detection systems. These systems provide continuous monitoring both at the network and host levels. Next is configure filters. We implement filters to restrict connectivity if a server is compromised. This filter enhances our control over potential security breaches. By promptly limiting access when a threat is detected, we can contain and neutralize potential risks before they escalate. It's about creating a dynamic defense system that responds swiftly to emerging threats. Last but not least is limit root access. By minimizing the number of individuals with elevated privileges, we reduce the potential points of vulnerability. Limiting root access is a proactive measure to ensure that only those who absolutely need such high-level access have it. For the next slide is securing user services. This is for ensuring a protected and resilient user environment. The first line of defense involves meticulous application control. By specifying permitted application in the security policy, it effectively controlling the software landscape on networked PCs. Moving on to endpoint security. It mandates the use of personal firewalls and antivirus software on network PC. This is the guardians at the user level, providing a critical layer of defense against external threats. Establishing clear procedure for the proper installation and regular updates of these security measures is crucial. Think of it as equipping each user with their own personal shield against cyber threats. Let's move on to the last slide for me, which is securing wireless networks. First is network segmentation. It places the wireless local area or WLANs in a dedicated subnet or VLAN. Moving on to endpoint security. It mandates the use of personal firewalls and antivirus software on all laptops. Last but not least is SSID and authentication management. Adding an additional layer of stealth to our network, it is important to use SSID. Furthermore, it enforces MAC address authentication for enhanced access controls. That's all for me. Thank you.